A separable differential equation is one in which our differentials, dx and dy, and our variables x and y can be separated by the equal sign so that all occurrences of x and dx and all occurrences of y and dy are on opposite sides of the equal sign. So here's an example in which we'll be able to solve the equation using the method of separable equations. The first thing we'll do is multiply both sides by dx, and at the same time we'll divide by x and divide by y. So that brings the y to the left side, so we get dy over y, brings the x underneath the 1 plus 2x squared, and we've got the dx on the other side. Once you have them separated, then we can integrate both sides. I split the right-hand side up into two separate fractions, or two separate terms in fact, and then one of the fractions reduces to 2x. We find the antiderivatives of these. An antiderivative of 1 over y is natural log of y. Antiderivative of 1 over x is natural log of x, and the antiderivative of 2x is x squared. Now, because I have x and y both greater than 0, I don't need to worry about absolute values on these. And what we often want to do is solve for y. And since its natural log of y is equal to all this, if we raise both sides, e to both sides of the equation, we end up with y equals e to that side. Sometimes these can be simplified. Now, remember that we add exponents when we're multiplying things with the same base. And so e to the natural log of x plus x squared plus c could have been obtained by taking e to the natural log of x multiplied by e to the x squared multiplied by e to the c. E to the natural log of x is just x. E to the x squared will just leave as e to the x squared. And here's the kind of unusual one, e to the c. Since c is a constant, e to the c is also a constant, so we'll just name it a different constant. And so we end up with a x e to the x squared. The a being the e to the c here, x being e to the natural log of x, and e to the x squared coming from that. That's just a solution. It's a general solution. It does not involve any initial conditions. And so the next example we'll look at will involve some initial conditions. So we want to solve this one, e to the t dq dt equals t over q, and we know that q of 0 is equal to 1, and again we're going to assume here that q is positive. We do the same thing we did before. We want to separate our variables, multiply both sides by q, we get q dq. Multiply or divide actually both sides by e to the t, which would become t over e to the t, which if I think ahead about finding an antiderivative, I don't know how to find the antiderivative of that. And so we'll write it as t e to the negative t, and we'll see in just a moment that we'll need integration by parts. We also multiply both sides by dt to get that to the right-hand side. Now we integrate both sides. As I mentioned before, we need integration by parts. So u is going to be t. Everything else, e to the negative t dt, will be dv. Find the antiderivative of dv to get v is the opposite of e to the negative t. Take the derivative of u, and we get dt. du equals dt. We'll substitute those in. At the same time, we will find the antiderivative of q. We get 1/2 q squared. U times v is the opposite of t times e to the negative t, minus the integral of the product of these two, but because one of the factors is negative, the subtraction becomes addition, and we just have the sum of the integral from e to the negative t dt. Now notice I didn't put a constant. I didn't mention this before. I didn't put a constant on this side because technically I could, but I'm also going to end up with a constant on the right-hand side, and if I combine those two constants, I just get another constant. So we just typically do one constant at a time. When I find the antiderivative of this integral, I have the opposite of e to the negative t. So now we're going to take advantage of our extra information, the initial condition, q of 0 is equal to 1. So I'm going to replace all of my t's by zeros, replace q by 1. So 1/2 of 1 squared basically is equal to negative 1. This is the only thing that survives those zeros. E to the 0th is 1. So we have minus 1 over here, If we add 1 to both sides, I've got 1/2 on the left side, add 1 to both sides, I get 3/2. So 3/2 is going to be what my constant is. So we're going to put that in. Our constant is 3/2. And as I said before, we like to solve for q. And in this case, so I'd multiply both sides by 2. And because q is positive, when I take the square root, I'm only going to get the positive square root. And I'll just rearrange the terms back here to make things a little prettier. It's going to be radical 3 minus 2t e to the negative t minus 2e to the negative t.